Hello and welcome. Hi Joseph, how are you? Today we're going to answer all of your questions, anything that you have on the go for math, for science, for grade 8, for French, for English. You let me know and I will answer them. You just type it in the chat. Okay, so I just got a question about GCF factoring, so I'm going to do that first, and then while you guys are still typing, I'm going to try this out first. So when we have this polynomial here and you want to factor out the GCF, just find the largest number they have in common. So right now we have 3 and 12. The largest number they have common is 3. And then you look for the most letters they have in common. So for the x, you can see we have 5 here, and for the x over here, we have 6. So you always want to go with the lowest power. So the lowest power is 5, so they have at least 5 in common. So 5, and then for the a's, same thing. They both have a's, so the lowest power on my a's right now is 2. Then we go, what times our GCF will give us our first term? So 3 times 1 is 3, so we don't have to do anything. X to the 5, we don't have to do anything. But we are missing a couple a's. This one has a to the 5. This one has a squared. So we just have to add 3 more a's. So we'll go a cubed. Then, after that, we have this term. So 3 times what is 12? It's 4. So we have plus 4. Then, for the x's, we're missing 1 because we have 6 over here and we only have 5 here. So we're just going to get an x in there. And then for the a's, we're good. We don't need any more. And there you go, GCF factoring. Awesome. So let me know what questions you have. Okay, could you possibly do a comparison? Yes, I can. In what sense are you looking for? Give me 1 second. I'm just gonna grab my biology stuff. Give me 1 sec. Oh, there we go. So is there something, so Joseph, is there something specific you were looking for like the comparison, or were you just kind of thinking about like knowing it all from the beginning? Just let me know. So just get my biology stuff. Okay, 1 second. Okay, so for okay, so if you want just kind of like basic, then the basic would be something like, so for a woman, her ovary goes through meiosis, and then the ovum. So for example, if we say a haploid would be N, and then a diploid would be 2N. Then the ovum has the haploid, and then it goes through fertilization, and it gets a zygote. So basically, you have the ovary, and it goes through meiosis, and then that goes to the ovum, which that's where your N is, that's where you have your haploid, okay? And then you have your fertilization. And then after that, it becomes a diploid, which is your 2N, okay? And the N being like 23 gametes, okay? All right, and then so this is gonna be your 2N, so you're gonna have 46 gametes, okay? And then basically mitosis and development again. And so, and development. And then after that, so for testes, then it goes into for the sperm. And the sperm, of course, that's going to give you your other half there, right? And so that goes into the fertilization as well. And that's where you kind of get everybody together. Yeah, that's pretty much, it's kind of like a comparison of how they work together. So each parent is going to donate half of gametes that you need. So I'm not sure if that answers your question, but hopefully that's a quick comparison for you there. Any other questions? Keep texting them or typing them. Also, guys, happy spring. Today's the first day of spring and it's super sunny out. That's very nice. Good morning. So how does this, Emma? So basically, guys, you can explain what energy can. Okay. Yes. Yes to Emma. So in general, guys, just a couple people are asking like, how does this work? So basically, type a question in, ask it to me, and I will try my best to answer it, teach you it, and then maybe I'll give you a challenge question, whatever. Just like you guys are in tutoring, you guys can ask us questions and we'll go over stuff, okay? So type it in. If you're having a problem typing it in, and I know if you're one of my students already, you can text me a picture of what it looks like, and I can also take it from there as well, okay? So depending on what unit, Emma, that your energy pyramid's from, like there's the basic one of biology, and that looks like you have your producers, and then you have your herbivores, and then you have your carnivores, and then you have your top predators. Okay, and so you have the sun, which also gives energy to the producers. Okay, so there's a lot of energy here. In the form of matter and ecosystem. Okay, okay, I'm gonna finish up this. So basically, the producers are giving energy to the herbivores, and it keeps kind of going up. So that's your basics of the pyramid. But I know what you're thinking about now. So give me 1 second.
Who is this? Hello? Paige.
Not Paige. Yeah,
Emma.
Paige is writing, but Emma, what's up?
Energy and matter in the ecosystem. All right. So where does energy come from? What's the first source of energy? Anyone know? It's the sun, right? Yeah, so we got the sun. Yeah? So the sun radiates energy down in the form of light. Okay? Now who's absorbing the light? That's our plants. Our trees, right? Our grasses, shrubs, whatever. So these guys are absorbing the light energy, and they undergo photosynthesis. And what's the purpose of photosynthesis? So they're going to produce sugars, all right? Yeah. So the plants absorb light energy and create sugars. They produce sugars. And then that's what the animals start to eat. So you get the cows, all the herbivores, they eat the plants and absorb the sugars. And then that's energy entering their system. And then they grow, right? And then you have some carnivores that feed only on the herbivores. And then you have such a thing as omnivores. They eat both plants and animals. Humans are an omnivore. I have my salad and I have my steak, right? And that's how energy is entering the ecosystem. Now, when a plant or an animal dies, we decompose, right? And the energy is returning back to the ecosystem. And fungi, like mushrooms, play an important role in the decomposition, and they return the nutrients back into the soil. Making sense? Yeah, okay. Anybody else have any other questions? Math, science, physics, chemistry, biology? Yeah, I think it answered your question. Okay.
Awesome. Okay, perfect. Okay, so John and I are doing this in tandem. And so, yeah, so Just keep asking questions. You guys subscribe to my channel, right? So, okay, I just got a text from one person, so I'm going to answer their question, but guys, keep texting me in questions, okay? So they said if the x-coordinate, so this is from grade 12 math trigonometry. Or grade 12? Yeah, grade 12. So if the x-coordinate is 2 over 3, then they wanted to know what is the y-coordinate. So it says determine the coordinate for all the points on the unit circle that satisfy the conditions. And the x-coordinate is 2 over 3. And it says, so basically we just have to find the y-coordinate where that is, right? So all you need to do is you know that the unit circle, okay, it's about a circle, but that's okay. The unit circle has the radius of 1, right? And so we can use, and they also make the right angle triangles. So we can use the Pythagorean theorem. So we have x squared plus y squared equals r squared. R being the radius is 1, and 1 squared is just 1. So then we have 2 over 3 squared plus y squared. Yeah? Then we just have to do it. So 4 over 9 plus y squared equals 1. Take your 4 over 9, pop it on the other side, solve for your y. So y squared equals 1 minus 4 over 9. And then you're going to take the root of that as well. So y equals plus or minus. So if we actually do this out, we will end up with 5 over 9. And then you can just split the root between the top and the bottom, right? So we have plus or minus root 5 over 3. So from here, you're going to get 2 points, all right? You have to write your coordinate points. If you don't write your coordinate points, you do not answer this question. So we have 2 over 3, root 5 over 3. We have the positive one. And we have 2 over 3, negative root 5 over 3. Some teachers may ask for what quadrants will that be in. So if we look at this, where is x and y positive? Quadrant 1. So this would be your quadrant 1. Where is x positive and y negative? So x is positive, y is negative. That's quadrant 4. There you go. Who's next? Guys, make sure you type me in your questions so I know what to do. I know some of you are working on negative, thanks, John. I know some of you are working on negative exponents or exponent rules in general. Like we have a lot of grade 10s right now. So I'm going to do some of those because it's good review. So this does relate to grade 10 math. However, this will be grade 10, grade 11, grade 12 math right now for negative exponents. So an exponent rule. So if we have something like, I don't know, 5 over x to the 6, y to the negative 7, 10, a to the negative 2, y to the 3, all to the negative squared. So yesterday we were talking about this a little bit, but we'll talk about it again. You have two ways to do this right now. You can clean up the middle, or you can deal with the negative and 2 on the outside first. Personally, I like actually cleaning up the middle first because it gives me less to work with later on. So I know that 5 and 10, and you can actually circle these numbers. So if you want, you can say I'm just dealing with the numbers right now. So here we go, just the numbers. And so that's going to give me a fraction. So I have 5 over 10. I can reduce this fraction. So what divides into 5 and 10? 5, right? That's going to give me 1 over 2. So I know that this is going to be 1 over 2 inside of my fractions. Thanks, John. Then I know that, so for the x, I have nothing matching on the bottom, so I'm just going to leave it. The y's, however, I do have something matching. And so when we have a base divided by the same base, what do I do with their exponents? Chat it in so I know you know. Yeah, you subtract. Good job. And so this would be y, and you're going to have, we can just do it on the outside. We have minus 7 minus 3. So this is going to be y to the negative 10. Okay? Where this is negative as our result, we're going to put it on the bottom. So instead of the top, we're going to go straight to the bottom. Because it is negative, when we have a negative exponent, we do take the reciprocal, right? So if I have a to the negative 2, that's going to be 1 over a squared. So take the reciprocal, change it to a positive exponent, okay? Good. So then we didn't deal with the negative 2 on the outside, and also don't forget to put your a to the negative 2 in here as well. Because it is a negative 2 for the a, we can actually move that guy to the top. And so this is kind of a cleaned up version of the inside. Then the only negative exponent I have left to deal with is this outside guy, okay? So take the reciprocal, right? The negative tells us take the reciprocal, which just flip the base. So we have a squared, x to the, oops, sorry, I wasn't gonna flip it. 2y to the 10 over a squared x to the 6. Then our exponent now becomes positive. Okay, so we flipped the base, got rid of the negative. Nothing in the middle became negative. Did you notice that? So I didn't put a negative sign here because the negative does not mean times by negative. It just means take the reciprocal. I'm spending a lot of time on that and keep repeating myself to ensure you know it. Now, super simple after here, you just pop the 2 into everybody. So we have 2 to the 2. We have y to the 10 to the 2. So when we have an exponent to an exponent, we multiply the exponents. So it's going to be 10 times 2, which is y to the 20. Then we have a squared, and we have it squared again. So we multiply, that's a to the 4. And then we have x to the 6 times 2. So we have x to the 12. And then you know that 2 squared is just 4. So you could just, if you didn't want to write the 2 squared, or you just want to get rid of it, because you don't want to write everything else, you could just put a 4. Sound good? Negative exponents, super important. So now I will give you a question. So while I'm waiting for you guys to type in your questions or text me, I'm going to write another question on the board you can work on. So give that a go. And in the meantime, if this is not your grade or you already are a pro at this, just text me in some questions and I'll get those ready right away. $25 on the top, yeah. So 25 over 100. I'll write that a bit clearer. Don't you deal with the A's first. You can deal with the A's first if you want. That's up to you. You can deal with the numbers first. Like if you want to clean up the brackets on the inside, do the numbers, do the A's, leave, like you don't have any B's and X's together, so you just leave those. Yeah. Yes, you do pay attention to BEDMAS at all times. So there's never a time, once you've learned BEDMAS, I think they start with grade 7-ish, you always do BEDMAS. So that's a guarantee all the time. Good question. And so like that's why I say like brackets, do the brackets first, what's inside, clean it up, then do your outside exponent, and go from there. Why, yes, John. Yes, it is. Okay, well, let's go. So if you have the number, so 25, Brody, what is multiplicity again for math 30? Okay, Brody, I'm just going to finish up this question and then I'm going to get back to multiplicity. Thanks for the question. So right now we have 25 over 100. And so 25 over 100, that can reduce, right? So 25 over 100. They can both divide by 25, right? So divide by 25, divide by 25. We get 1 over 4. So that's reducing the numbers first. Okay, then as John mentioned in the chat, we have your A's to clean up. So we have 4, we have A over A, subtract. We learned that last question. So we have 4 minus 2. So that's x to the 4 minus 2. And that 2 minuses becomes addition, don't forget. Okay, so this is going to be x to the 6, positive. We're going to put it on the top. We don't have any B's or, oh no, sorry, not X, sorry. That's A, my bad. We don't have any other X's or B's, so we can just leave what we have there. Okay, and then we have negative 3. So now, following BEDMAS, as Joseph indicated, what we had the brackets, and then we are now dealing with the outside exponent, okay? So it says negative. Negative means flip the base. So if we flip the base, we get 4x to the negative 6, a to the 6, b to the 5. So notice a couple things here. One, my exponent now became positive, okay? And sorry, I just read some of the chat. Okay, my exponent became positive, and notice that the exponent on the 6 is still negative because we did not deal with the negative on the 6. We only dealt with the negative on the 3, okay? So now we can just apply these guys in if you want, right? So it becomes 4 cubed x to the, and this is negative 6 times 3 because it's an exponent to an exponent, all right? So negative 6 times 3, so that's negative 18. And again, 3 times 6 is a to the 18. 5 times 3 is 15, so we get b to the 15. And then for your final answer, we have 4 cubed. Does anybody know what 4 cubed is? $64. So 64. And then you'll notice that this still has a negative. We're going to take them downstairs because we take the reciprocal. All right. So we have a to the 18, b to the 15, x to the 18. And that should be your answer. Okay. So I'm going to leave that up there for a second. Yeah, 64. Good job, Brody. Let me just read some of these questions. So I'm going to go multiplicity next. And then why is biosphere considered both an open system and closed system? Okay, we'll go over that. And then Emma. Okay, so John just answered. So Paige, check out the chat because John just answered what the question you had asked. I'm going to go over Brody's question with multiplicity right now. So multiplicity, here we go. Okay, so we have the ones that you have gone over in grade 12 are 3 types of multiplicity. So multiplicity relates back to the x-intercepts basically. And so for example, if I have this graph has a multiplicity of 1. Okay, one x-intercept, it passes between one quadrant to another. It passes through. One x-intercept, multiplicity of 1. Okay? When a graph touches the x-intercept at the same point, sorry, not same point, when a graph touches the x-intercept, so that's generally when we get into curves, okay? This is going to be the double root. So perhaps it's a perfect square, like maybe this is y equals x minus 2 all squared. So your intercepts are 2 of the same, okay? That means you have a multiplicity of 2 at that point, right? So multiplicity of 2. Okay? And then the next one that you're going to deal with is a multiplicity of 3. So that's kind of when the curve gets a little bit lazy, I like to say. And so it kind of lays on the axis a little bit. So that'd be like a cubic. Something like this. So here, you would have a multiplicity of 3. Okay? So making up an equation, maybe we have x minus 3, I don't know, cubed, right? So it has a multiplicity of 3. Now, so you have 3 types. You have one when it passes through, multiplicity of 1. You have one when it touches, multiplicity of 2. You have one when it kind of lays on the axis and goes, it's multiplicity of 3. Then, if you have your equations, for example, if you have something like y equals x minus 2 squared, x plus 1, x minus 3, all cubed, then you can say what your each factor has a multiplicity, right? So this guy would have a multiplicity of 2, and look at its exponent, it's 2. And this one has a multiplicity of 1, multiplicity of 3. Sound good? Okay, so you got John on questions on the chat here, which is awesome. Thanks, John. And then I'm on the board, so you guys got full access to us, which is great. Awesome. Emma, do you want me to go over converting units? Does anybody want me to go over unit conversion? I can. Oh, since I'm waiting for you guys to type in your questions, I'm going to do it anyway. Okay, so converting units. So converting units is going to relate to your sciences. It's going to relate to your math. Yeah, that's pretty much what it does. So an example, and I know a lot of you are studying for your math midterms. Okay, so sorry. So a lot of you studying for your math midterms too, so I know this is definitely going to help. Let's go with, we're going to go with metric to imperial. So let's just say we have 5 meters. Let's make it 15, just because it's good. So we have 15 meters, and the question would be something like, what is that in feet and inches, right? So because it's not going to convert just on a solid number. They want to know what is the feet in inches, and it's a very classic exam question. So we need to set up our unit conversions. So 15 meters, then you guys will have a unit conversion on your sheet. I'm just going to grab it. Mine, 2 meters. So yeah. So basically, it is 3.2. I got 3.28. I don't know what you guys have on your actual formula sheet, but I'm going to use this. So for every 1 meter, I have 3.28 feet. Okay. And then if we use a calculator to find out what that is, also with unit conversions, even though this is, I know we're doing imperial and metric right now, but it's like anything. It happens in your chemistry, in your physics, possibly biology. But whatever you have on the top must match what you have on the bottom. Okay? Whatever's on the top will match what's on the bottom. So these go out, I'm left with feet. Okay, so then let's just do that. So 15 times 3.28. So we get 49.2 feet. All right. And so since we want feet and inches, you can't leave it as 49.2. All right. You have to convert it fully. So the only thing we're going to left to convert is going to be the decimal. So it's just going to be this part right here. So we have 0.2 feet. And then we know for every 1 foot, because we're going to inches this time, for every 1 foot, there are 12 inches. And so 0.2 times 12, we get 2.4. And so for this question and what your teachers are expecting of you now, you would basically just say you have 49 feet, and this you can just round down because they don't go, you guys don't focus on anything less than an inch. So we'll just say 2 inches. And most times they'll give you something that works out perfectly anyways. So when you get it into the feet, only pay attention to this decimal right here, convert it, but when you get down to inches, the decimal mean round up or round down. Yeah, so that's a good question. So generally, so the question is, should I round down? So if it doesn't say where to round to, where should I round to? In general, it kind of depends on the question. So if you had a word problem, you need to do something that makes sense, right? Like if you're doing something with money, you wouldn't say like $5.689 because nobody knows what that means. But you could say $5.69. That's okay. If you're dealing with measurement, I mean, to the nearest 10 to the nearest 100, that's generally a good rule. If it's on the Vista Virtual School, which I know a lot of you are on, then I would say go to the nearest 10 would be fine. But I would show my roundings, right? So what I mean by that is in your guys' answers, you want to have something like, if you knew this was 5.96, or let's make that an 878, right? That's what your calculator gave you. Then I would show that it's 5.9. But what I would not do is if my calculator gave me this, I wouldn't just give them 5.9. I would show them what the calculator gave me, then I would show them that I rounded, and that would be sufficient. Because then they can see, and they didn't ask either, so show them that you rounded and you'll be fine. And just make sure if it's a word problem, stay within the context of the problem. What's next, guys? We can do some more exponent stuff if you want. I know that can always be challenging. Or so if it doesn't say where to round to, nearest 10th or 100th is fine. Later in science, yeah. So later in science, it gets really specific. So sometimes you have like, you have to pay attention to your significant digits, right? No. Okay. Would you like me, and I can do it, would you like me to do some polynomial stuff? Because I know a lot of you are going into that chapter. So I'm going to let you guys, oh, sure. Okay, I'm going to let you guys keep typing up questions. I'm going to go over some polynomial stuff. So I'll just give you kind of a bit rundown of the basics here. So we have x is a variable. We have maybe a 5. So when you have just a number, it is a constant. If I have a number in front of the x, the number is now called a coefficient. Okay? So then you have to know the difference between monomial, polynomial, all that stuff. So we have a monomial would just be one term. A binomial is 2 terms. Okay. A trinomial, 3 terms. Okay, and the last one is a polynomial, and a polynomial is anything more than 3 terms. So maybe we have 5x cubed plus 2x squared plus 3x plus 6. This is a 3, we'll say 3 plus, meaning 3 or more terms. Okay? So there is your monomial, polynomial, monomial, binomial, trinomial, and then, polynomial. Okay, and then you guys are going to go into addition and subtraction. And so even if you haven't gotten to this chapter yet, it's coming, and it's good review and it's good notes. So when you do addition and subtraction, okay, so addition and subtraction, same rules. You just need to add like terms. So add or subtract like terms. Okay, and so 5x plus 2x, those are like terms because they both just have an x to the power of 1. It's fine, you can add them. So this is going to be 7x. But if you had 3x plus 2x squared, you cannot add these, okay? They do not have the same power on the x. They're not like terms. So not like. All right? So a lot of your questions are now going to be like for addition and subtraction, they're just going to say combine like terms, simplify, whatever. Okay, so maybe you end up with something like this, all right? I'm going to give you a second to try and add that together or subtract it, sorry, and combine those ones, combine the like terms together. Okay, so the 5x squared and the 2x squared, those are like terms. I can rewrite everything. Yes, we do need to apply the negative to everything. It's true. So if you want to rewrite this, then you can go 5x. So I'm going to show a lot of steps. Those steps you know, you can totally skip those. So plus 6x plus 3. So now this is technically like a -1 multiplied by this. All right, and so that means the negative is going to actually apply into everything. So we have -2x squared minus 6x minus minus plus 7. Okay. Then you can rewrite the like terms together. I mean, you can simplify from here, or you can just rearrange them. If you're going to rearrange them, do know that the sign goes with the term. So this is one term, one term, one term. This negative sign does go with this 2x. This negative sign does go with this 6x. And then this is your 7. Okay? So we can go 5x squared minus 2x squared. Then I have plus 6x minus 6x, because these are alike. So right now I'm just combining like terms together. And then 3 plus 7. Okay? And then the ones that are the same, you will now combine those. Okay, so I just rewrote it, and now we're going to combine. So 5 minus 2 is 3x squared. Do not change the x squared. Don't make it 4. Don't make it whatever, 0. Leave the x squared. That's part of the term. Just deal with the coefficients. 6 minus 6 is 0. When it's 0, I can write 0x, but you don't have to, because it's 0. It doesn't mean anything. It's gone. So those just go up. Then you have 3 plus 7. So 3 plus 7 is 10. There you go. So there's your subtraction addition, okay? The polynomials. How are you guys doing for questions? Do you have any more questions? Have you guys subscribed to my channel? Is this every day? So we're doing the online tutoring today. We're definitely doing it tomorrow. We're not going to do it on Saturday and Sunday just because it's the weekend. I'll give you guys the weekend off. But we are doing it throughout March break. I think it might be a little bit structured differently throughout March break. We might just go like to an hour a day depending on how many people are showing up. But that's where we're at right now. Good question. Yes, Emma, yes. Because 6 plus 6 minus 6 is 0, right? So if I have 6, I take away 6, there's nothing left. Good question. And then so right now, I know a lot of you guys are going online for school and stuff too. So they're trying to get some tutorials and different notes and stuff posted. So we can talk about that in your lessons, or if you have questions or anything, yeah, let me know. I am here. And so while I'm waiting for more questions, okay, so tomorrow at the same time. Yes, John, tomorrow I will be here 10 a.m. on YouTube doing live feed. Not to worry, all your questions will be answered. So I'm going to go over multiplication of polynomials. Okay, so multiplication you would have done in some grade 7 stuff, some grade 9, 8, 9, 7, 8, 9, and we're definitely focusing on it in grade 10. So for example, if I have 5x times 2x plus 1, then I'm just going to get rid of this stuff on the bottom. Hopefully that's okay. Then I basically just multiply this guy in, okay? And that leaves me with 10x squared, because 5 times 2 is 10. X times x, that's two bases the same, so we just add their exponents. Then you have 5 times 1 is 5, and then x, there's no x there, so this is going to be x. Okay, so that's basic multiplication. And then we can also beef it up a bit by adding in two binomials. And so remember, everything in the first bracket must multiply by everything in the second bracket. So this one times this one to start with. I'll give you a moment to try and do that by yourself. Okay, so 5 times 3 is 15. X times x is x squared. And then we have this guy. So 5 times negative 1 is negative 5x. 2 times 3 is positive 6x. 2 times negative 1, 2 times negative 1 is negative 2. And then, can you guess what we do from here? We simplify, we add the like terms. So yeah, good job, John. So here we have 15x squared. There's no other x squared term, so that is my x squared term. This has x and x, so I'm going to combine those. We have minus 5 plus 6. Minus 5 plus 6 is just 1. And then we have minus 2. And that's our answer. So this is called expanding. And the way we do it is called FOIL. So first, outside, inside, last. Okay? F-O-I-L. But it's actually called expanding. So in your questions, you'll see expand this or simplify this. You will not see FOIL this, because FOIL is a method on how to do this. Okay? Super important. So one more time, I did step 1, 5x times 3x. Step 2, 5x times negative 1. Remember, everything in this bracket must multiply to everything in that bracket. Step 3, we did 2 times 3x. And then we did step 4 was 2 times negative 1. From there, we just cleaned up our terms, combined them, and we're done. So there's your multiplication. All right? So yeah, so is there any more questions right now that I can answer? I'm gonna wait a couple more minutes, and because if there's no more, we can end it early today. It's no big deal. We are back again tomorrow. So if you want to go work on stuff, apply that. I know some of you doing this chapter are gonna go have to do some work. But yeah, do you guys have any more questions? I'll wait about maybe another minute or two. Can you type them in? Trig. Okay, what about trig? Just a refresher. Okay, I'll go over some stuff. I won't go over everything, but I'll go over some stuff, okay? So, grade 10. Let me see. Give me one sec here. So we know how to, let's start with labeling a triangle. So let's just say this is your angle, okay? Like rearranging, tan, -1. Yeah, okay, yeah, perfect. So let's start with just labeling first of all. So we have our angle over here. So, sorry, labeling. We have our right angle. Across from our right angle, our longest side, which is the hypotenuse. Okay, and then from there, we know anything across from the angle is our opposite because we look opposite. What's left over is our adjacent. All right, and so if we have a question, maybe it is find this angle when this side is 5 and this side is 7. So then we need opposite faces the angle. Good job. So now we need to figure out what is the angle here. So angle equals what? And so to do that, we need to look at our SOHCAHTOA, right? So SOHCAHTOA. All right. And so we label our triangle, hypotenuse, opposite, adjacent. We know we have the opposite, we have the adjacent and tan. Yeah, good job. So we have tan of the angle, which is opposite over adjacent. So we have tan of the angle is the 5 over 7. Good. Okay. And so you have two options here. You can divide this and get a decimal right here first, or you can move the tan over. Because decimals can be kind of like long and they can be weird, I probably want to move it over first. All right. So when we have theta by itself, you have to take the tan inverse. All right. So tan to -1, 5 over 7. And that, now you would just plug in your calculator. Make sure your calculator is in degrees, okay? Make sure it's in degrees. So tan inverse of 5 divided by 7. So we have theta, I got 35.5 degrees. Yeah. Okay, so if we know that this angle is now 35.5 degrees, we can also get the other angle even though we weren't asked for it. Do you know how to do that? So how do I get, we'll say this is called alpha. So how do I get alpha angle? Okay, so we remember that there's 180 degrees in a triangle, right? So if we have 180, we know this one's 90, we can subtract off 90. We know this one's 35.5, we can subtract that off as well, okay? And that'll give us our other angle. So 180 minus 90 minus 35.5, we get 54.5. Oh, okay, Pythagorean theorem, so hang on a sec with that. So for this, it's going to be 54.5 degrees, okay? Pythagorean theorem wouldn't help here because it doesn't use angles, but what Pythagorean could do is it could tell us what is h, right? So if we had to figure out what h was, let me just erase this top one here. So if we had to figure out what h was, we can say a squared plus b squared equals c squared. H being our hypotenuse, we can just say this is 5 squared plus 7 squared is c squared, okay? And then we have 25 plus 49 equals c squared. And then we would just add those together. And we get 74. Okay? And then just square root both sides. So square root, and I will, so that's 8.6. So C equals 8.6. So you can say your hypotenuse is 8.6. So again, I'm going to reiterate that. Sine, cos, tan are for the angles. Pythagorean theorem are for the sides only. Sine, cos, tan can also help you solve for sides if you want, because it is a quicker method than having to go through the Pythagorean theorem. Unless you're like super quick at math, then it doesn't really matter. But Pythagorean theorem, sides only. Sine, cos, tan, angles and sides. So they're a 2-for-1 deal. Okay. So I'm going to do one more thing because I know you had asked about solving for them. So I'm going to do one more triangle here. So let's just say, let's flip the triangle just for fun. Let's just say this, let's just go this time. I'm going to give you the angle. So I'm going to say this is 30, okay? And this is, I don't know, 6 sharp. And my question is, what is X here? And so this time we are looking for a side. So we could think about Pythagorean theorem. The problem is that Pythagorean theorem needs 3 sides. And so technically, we don't even know that side either, right? And so we would have a whole bunch of unknowns, not gonna work, okay? So what we would end up doing is we need to think about our sine, cos, tan. So SOHCAHTOA. Okay. And so who could we use here? Sine? Okay, so let's check. So we have the opposite and we need the hypotenuse. So then, yeah, opposite and hypotenuse, definitely it's sine. Good job. Okay, so we have sine of the angle is our opposite over hypotenuse. Sine, we know the angle, we're going to put that in. The opposite is 6, your hypotenuse is x. Okay? And so for this one, if you remember, my grade 11 physics teacher told me, or my grade 11 math teacher told me, you can just swap these out, right? And so we get x equals 6 over sine 30. And this you can just pop in your calculator. So 6 divided by sine 30, I get 12. So I get x equals 12. Yeah? And then now that you have a side, you could use Pythagorean theorem to solve for y. However, what if you made a mistake? Now today we did not make a mistake, but if I was on a test and I wasn't sure if I made a mistake, and I wasn't sure if I was right, and I could be right, I'd probably use what is given. So what is given is my 30 and my 6. And so I would probably want to use stuff with just those, okay? So if I did that, I'm going to have to go into another trig function because I don't know if this side is right. So I'm not going to use Pythagorean theorem. So I'm going to use trig, and knowing that this is my adjacent, what do you think I could use to solve for y? What trig function? So I have my adjacent and I have my opposite. So that would be the tan function. Yeah, good. So we have tan is opposite over adjacent. We know it's tan of 30. So my opposite is 6. This is opposite. My opposite is 6 over y. And again, we can just swap those out. It's the exact same one, exact same type of solving. So we have y equals 6 over tan 30. Okay, so 6 divided by tan 30. Again, make sure your calculator's in degrees. I get 10.39. So 10.39. Okay. Yeah, you're welcome. Okay, before you go, Emma, Just gonna show you this one last thing here. So let's just say I have one more triangle. And let's say I'm gonna do, this is 60 degrees. And this one, let's make this, I don't know, make this 4. And I want this one this time, okay? So if we label this is gonna be your hypotenuse, your opposite, and your adjacent, okay? And so what do you think we use for this triangle to solve it? So if I'm solving for x right now, my adjacent, not my opposite, sorry. So I need my opposite, I have my adjacent. Yeah, we're looking for tan, good. Okay, so we know it's tan of the angle is opposite over adjacent, so we know it's tan of 60. My opposite this time is gonna be x, my adjacent this time is gonna be 4. So the reason why I want to do this one is because now our unknown is on the top, all right? So before it used to be on the bottom for the last couple of questions, now it's on the top. And the question is, how do I solve it when it's on the top? So how can I get x by itself right now? So I'm gonna multiply both sides by 4, right? Because I gotta get rid of that 4. So I'm gonna multiply by 4, gone, multiply by 4, right? And so we have 4 tan 60 equals x. And yeah, good job. I think there may be a delay from when you're typing to when I'm answering too. And so when you get that on your calculator, I got 6.9. And so we get 6.9. And then at the end of the day, we're back in the same situation, right? So if I wanted to solve for the hypotenuse, I could use Pythagorean theorem because I have 2 sides and 1 unknown. I'm not going to use Pythagorean theorem, or I wouldn't, you can, but since I don't know if I'm right on a test per se, I would like to use stuff I was already given. So if I want to get the hypotenuse, I'm going to use the adjacent and the hypotenuse and the angle. Okay, so then you're looking at cos. Sound good? Okay, so let me know if you have any other questions. I'll wait for about like 1 or 2 minutes here. And yeah, you're welcome. Do you have any more questions? If no, it's all good. If you got to go practice that, that's totally fine. You're good for now. Awesome. Okay, great. So work on that then. Thanks for popping by. And so we're going to sign off as well. So tomorrow, 10 a.m., if you have any questions, let me know. I will be here, and we are doing check-ins at 9 as well. Okay? So I'll be on YouTube. Have a great day. Happy spring.